The Vanderbilt company began operating in 1964 in the city of Cuenca due to the demand of Ecuador's automobile industry. The company's prestige soon spread throughout the country because of its highly qualified and trained personnel, the use of current technology, and the best raw materials imported directly from Japan, China, and Mexico to manufacture steel springs for shock absorbers to be sold in the market as replacements. To this day, the raw materials arrive at the seaport of Guayaquil as high-carbon steel plates used exclusively to make coiled springs. Upon their arrival in the country, they are transported to the Vanderbilt factory, where they are inspected to verify that they comply with the technical specifications that guarantee correct performance when the steel plates are used to manufacture the final product. The steel plates are cut lengthwise according to specific measurements of each product's code. The edges of the steel plates are given form using heating and cooling processes to obtain the desired finishes. The edges are grinded and filed to meet the needs of the various design models. These different forms allow the springs to be attached correctly to each vehicle and to reduce the amount of friction between the different components. The lamination of the edges is done so that the steel sheets reduce friction and alleviate the rigidity of the springs at certain stress points. The next stage is a punching stage that includes a perforation in the center of the spring to allow the bolt that is used in almost all models to pass through the product. All the perforations that are made along the edges allow the springs to be held in place and correctly aligned. The punching is a precision process that makes the appropriate sized holes in the steel that permits the springs to be mounted to the vehicle's chassis using different support elements. During the mounting stage, the pieces are heated in ovens made specially for this process. Previous to this heating process, the creases and folds are made in the forming machines, and many of the principal sheets are attached to the vehicle using protrusions in one or both sides of the shock absorbers. It is common for the folds of a second steel plate to be attached to help support the extra weight loads for the models of heavyweight vehicles. The grinding and filing processes in cold permit the precise fitting of the springs with the suspension systems of the vehicles. All the operations for the specified designs of each product are strictly controlled and made in complete compliance with international specifications and standards. In the following stages, critical changes in the internal microstructure of the steel plates are produced to improve their future performance. Heating processes are used to increase the hardness and strength of the steel. The steel plates are heated to a critical temperature, and then they are cooled abruptly using a special oil created for this purpose. This heating and cooling process is completed at the same time that the curves for the various models are formed. Variables of control such as temperature, length of heating, and the speed of cooling are constantly monitored by capable personnel using software specifically designed for these processes. The annealing process is monitored by software created to alleviate the product's internal residual tension that is generated after the temple. This process allows the steel plates of the springs to acquire the necessary resistance and flexibility to perform well under maximum required conditions. The steel is submitted to tests of hardness and strength in a laboratory to assure that the heating treatments that were applied were effective. These strength tests are conducted using high-tech equipment that is calibrated according to international patterns and specifications. The steel plates are then cleaned to eliminate the slag generated by the grinding and annealing processes. Using a modern machine, hardened iron balls or spheres are shot at high speed at the steel plates to alleviate the surface tension. This is referred to as shot peening. In addition to increasing the durability of the product and its resistance to wear, it also prepares the surface of the steel for the painting process that is to follow. Powdered paint is applied to the steel plates using an electrostatic system. After the paint is applied, the steel plates are submitted to a two-step curing process using an oven with infrared panels and forced convection. The painting process used assures that the international standards required in the manufacturing of original shock absorber springs, such as saline resistance and covering thickness, are met. These international standards also need to be met in the manufacture of spare replacement parts. The steel plates have eyes that generally are required to be attached to axles using a pressing process that guarantees perfect mounting on the vehicle. Once the axles have been painted and the springs assembled, a final control to verify the quality of the springs is done before placing the products on the market. The camber machine is used to test the resistance of the springs according to the norms that each model requires. Labels that include a detailed coding of the make and model of the vehicle, an internal code, and a factory lot number that permits easy and effective tracing of the manufacturing history are placed on the surface of each product for identification purposes. After all the before-mentioned processes are concluded, a final test is made. The steel springs are placed under constant pressure that simulates the working conditions of the springs under maximum weight loads. This destructive or wear test is applied to various samples in order to guarantee that the shock absorber springs are durable and long-lasting. In all the different manufacturing processes, the international standards and norms set by the Society of Automotive Engineers are followed. Prior to the finished products being classified and stored in the company warehouses, according to their design codes, all of the lots are once again inspected to assure that no problems of quality exist. Present stock includes both individual steel plates and completely assembled shock absorber packages. The final products are distributed using a complete commercialization system that includes distributors and sub-distributors in principal cities located throughout Ecuador. These distributors maintain enough stock to meet the growing demand for the products on a national level. This is how the steel springs that thousands and thousands of vehicles used in Ecuador have in their shock absorbers are manufactured. For over 50 years, the Vanderbilt company has responded to clients' needs for quality automotive parts, and it will continue to meet those needs in the future. During the last few years, production has increased and control processes have improved with the advances made in technology. In the year 2002, the Vanderbilt company was recognized and awarded the certificate of ISO 9001-2000, and in 2008, the ISO TS 16949. The company has been at the forefront of the field, providing quality products required by the automobile industry. It employs all the necessary processes and controls to offer the best quality and assure total safety. We are the Vanderbilt Spring Company.